students, myself Jyoti IS, tutor of Saraswati Tuition Davangere. Welcome to my class Maths with Jyoti Ma'am. Today it is a class for 8th standard students Cbse Ncert in that the chapter first, that is the rational numbers. Now let us discuss about the what are rational numbers. You know very well about the natural numbers and also the whole numbers, integers, and now you are studying about the rational numbers. Natural numbers are those numbers which are counting numbers. 1, 2, 3, 4, etc. up to infinite are called the natural numbers. And the whole numbers. Whole numbers are the natural numbers along with 0. Integers. The integers consist of the positive numbers, the negative numbers along with 0. But rational numbers. Now let us listen. Rational numbers are those numbers which can express in the form of P by Q. Rational numbers are those numbers which can be expressed in the form of P by Q, where P and Q are integers. P and Q are integers. Integers and the denominator Q not equal to 0. Q not equal to 0. This should be the integers. Integers must. What is that? The 1, 2, 3, any positive number or any negative number. But the denominator Q should not be equal to 0. This is the introduction class for rational numbers. In this class, you are studying about the properties of the rational numbers and the methods which are following to solve the problems which are in the exercises. Now let us study the properties of the rational numbers. Properties. First one is closure property. In that, that one is closure property of addition, subtraction, multiplication, and division. Let us check the closure property for the rational numbers for addition, subtraction and multiplication and division of the rational numbers. Let us check what are in case of addition. In case of the natural numbers, you studied the closure property, isn't it? In that, when we add two natural numbers, the sum will be a natural number. In the same case, in the same way, for here, if it is A plus B is equals to C. In case of a natural number, you studied that when two natural numbers are added, the sum will be also a rational, also a natural number. The same is applying for the rational numbers. Let us consider A is an rational number and B is also a rational number. Let us take examples for two rational numbers. A is a rational number. Let us check for addition of the rational numbers. Let us consider the rational number, that is for A, that is 2 by 5. Another rational number, that is 1 by 5. Okay, if we add these two rational numbers, its sum will also be a rational number. Let's check. This denominator is 5. We are adding the numerators, that is 2 plus 1, that is equals to 3 by 5. Yes, this is also a rational number. Therefore, we check for the addition of two rational numbers is also a rational number. Now, let us check for subtraction. Subtraction of the rational numbers. Because in that case, the general form A and B is a rational numbers. The difference of those is also a rational number. Let us check by taking the examples. Consider n. A is a rational number. An example for a rational number is 1 by h minus 2 by h. That is equals to h. That is minus 1 by h. Here we got two rational numbers. We are taking the difference of those two rational numbers. The difference is also a rational number. It is also a rational number. Next, we are checking for multiplication of the rational numbers. The general form is A into B is equals to C. Consider two rational numbers. That is, for this 3 by 2 into 2 by 3. 2 by 1. Even 2 by 1 is also a rational number, isn't it? If you multiply these two rational numbers, this will be 3 2s are 6 by 2. 6 by 2 is also a rational number. Now let us check for division of the rational numbers. Okay, here for division A divided B is equals to C. Let us check for this. Here consider any rational number, that is 3 by 7 divided by 2 by 7. Okay, simplify this. That is equals to 3 by 7 into 7 by 2. Here we got 3 by 2. 3 by 2 is also a rational number. But in some cases, when b is equals to 0, the division of the rational number is not closed under division. It's not holds good for the division of the rational numbers. In case of when b is equals to 0, when b is equals to 0, this property now holds good. Understood? Now, let us move on to our next property, that is commutative property. Let us move on to the next property, that is commutative property. Commutative. Let us check for commutative property. In case of natural numbers, you studied the commutative property of addition, isn't it? The general form it is when we add two natural numbers in any order, those will be same. A plus b is equals to b plus a. Now, here we are considering a is a rational number and b is a rational number. The sum of these two rational numbers, if you add these two rational numbers in any order, the sum will be the same. We have to prove by taking the examples. For a, we are taking 2 by 7 plus 1 by 7. Okay, let us check it for a plus b. A plus b is equals to 2 plus 1 is 3 by 7. For LHS we got 7. 3 by 7. Okay. Now let us check for RHS. That is equals to b. b is any rational number. That is, we are changing the order of the addition. we are adding the b plus and then adding a. Here b plus a, that is 1 by 7 plus 2 by 7, that is equals to 3 by 7. We got RHS is also 3 by 7. By comparing LHS and RHS, we came to know that LHS is equals to RHS. Therefore, commutative property of the addition holds good for the rational numbers. Isn't it? A plus, if you add the rational numbers in any order, here we are taking the first rational number and the second rational number. Here we are taking the second rational number and the plus rational number. Next, commutative property of subtraction. Let us check for subtraction of the rational numbers. Here we are the two rational numbers a minus b, checking it for b minus a. Taking some example, we are taking simple examples because to understand easily, you can understand very easily the concept. Okay? A minus b. Take an example, consider a rational number, that is 4 by 5. Okay, another rational number, those are 3 by 5. Solve for this. 4 by 5 minus 3 by 5. What we got? Denominator is same. 4 minus 3 is 1. Here we got. LHS we got is 1 by 5. Here we are changing the order of the subtraction. Here we are taking the second rational number first and the first rational number second. That is, here the second rational number is 3 by 5 minus 4 by 5. Okay, here 3 minus 4 minus 1 by 5. Here we got in the RHS, we got minus 1 by 5. The LHS is 1 by 5. In the RHS is minus 1 by 5. Those are not equal. LHS is not equal to RHS. Therefore, commutative property of subtraction not holds good. Okay. Not holds good for rational numbers. Now let us move on to the multiplication of the rational numbers. Commutative property under multiplication. Multiplication. Consider two rational numbers, that is a into b is equals to b into a. Consider two rational numbers. The first one is, come and tell me, 5 by 8 into 1 by 2. Okay, solving for this, that is equal to, here directly we have to multiply 5 into 1, 5, 8 2 is 60. Okay, we are changing the order of the multiplication. We are taking the second rational number first here. This is the latest we got is 5 by 16. Here in this 1 by 2 taking first and 5 by 8. That is equals to 1 5 is 5, 2 8 is 60. What we got? The LHS is equals to same. LHS is equals to RHS. Therefore, commutative property of multiplication holds good for the rational numbers. Now let us move on to the division. Check for division of the two rational numbers. Division. Let us consider two rational numbers. A is an irrational number and B is an irrational number. Checking for commutative property. That is B divided by A. Now let us consider an example for rational number. That is 3 by 5 divided by 2 by 8. Okay, this is another rational number. 3 by 5. If you simplify this, 3 by 5 when divided changes into multiplication, it will be, we are taking the reciprocal of this number, 8 by 2. Therefore, 24 by 10. LHS we got is 24 by 10. Here b divided by 8. The second term is 2 by 8 divided by the first term 3 by 5. 2 by 8 is there. When we change to this is 5 divided by 3. 5 2s are 10 divided by 24. What we got in RHS? Are both equal? No, LHS is not equal to RHS. LHS is not equal to RHS. Therefore, commutative property of division does not hold good for the rational numbers. Okay, this is the commutative property.